My name's Russ Roberts. I'm a product engineer on the online team. And over here is Kristian Ekenes, and he's also a product engineer on the JavaScript team. So we're here to talk to you about how you can create your own 3D object scene layers and use them in your own custom application. So this is a pretty comfortable demo theater that we're doing. Let's see this. There we go. In this, I'm just going to be talking about using how you can do this with ArcGIS Pro or ArcMap. You could also use City Engine, that other desktop application for creating multi-patch data that you can use to create a 3D object scene layer. In this case, I'm using ArcGIS Online to generate and store these scene layers. But you could be using your enterprise portal like 10.4 or 10.5 to generate the scene layers to use also in a custom application. So it's not just ArcGIS Online, it can be ArcGIS Online or your portal that you could be generating them. And in this case, this workflow, I'm going to be creating hosted feature layers and scene layers. I don't know if you saw the plenary demo this morning where I talked about the trees in New York City. Well, this is pretty much the exact same workflow, but talking about how I generated all those New York City buildings instead, so the 6 million buildings in the case of this data set. And then Kristian's going to be showing you how you can take these scene layers that I'm publishing and bring them into the API. So some of you might have some questions like, what are 3D object scene layers? They're one of our 4 scene layer types. And you might have, they were all kind of talked about this morning in the plenary. We have the point scene layer that you could use for trees or hydrants or other point data sets. Then we have the 3D object, which we're talking about today, which is going to be the like New York buildings. You could also create multi-patches that could, in some cases, represent a pipeline or other features in the real world. We also have another scene layer called integrated mesh, which is generated from drone to map or like one of our providers like Vricon, which pretty much captures photos and it's able to generate a 3D realistic kind of layer, kind of like the Yosemite demo. That was the integrated mesh layer. And then the most recent one is the point cloud scene layer generated from last data. And that one can be generated from ArcGIS Pro. In this case, for the 3D object scene layers, we're starting off with multi-patch features. And those can be created in Pro, like I mentioned earlier, or ArcMap, and even exported out of City Engine. They can be textured or untextured, so that means, in this case, I'm just going to be using untextured buildings, but the textured ones could actually be styled to look like realistic buildings. So you could use City Engine or Pro to run a rule package to apply a certain texture to your multi-patch features. I'm generating these scene layers, in this case, from a feature layer, but you could also use scene layer packages. And scene layer packages can be used in the disconnected scenario, or you can upload them to ArcGIS Online or your portal to start publishing an actual scene layer. And then, in this case, I'll be using a feature layer, publishing it in ArcGIS Online. And we'll show you there's some benefits with doing that, coming from either pop-ups and renderers and filtering. We'll be talking about the filtering in our session on Thursday into a deeper dive of creating a bigger custom application. And the other thing about these scene layers, they're not, in this case, I'm just going to be using them in a global scene, which means it could be using a WGIS84 coordinate system, or it could be using WebMercator in the global scene case. But for local scenes, which I showed in the earthquake demo in the plenary, that those can be either WebMercator or any other projected coordinate system. So when you're cooking this data and you're thinking about it, you want to understand what coordinate system you want to be using it in. Because it's all cached data, it won't be reprojected on the fly like a feature layer or like a dynamic map service would be. So you kind of have to think about it in the case of a scene layer is dependent on the coordinate system, just like a tile layer that you would be using, because we're a lightweight application, and so we're not going to be trying to reproject those on the fly like Pro can. So let's just talk about preparing our data, and I'm just going to walk through some of the steps outlining how you can actually do this. Okay. So first up, in Pro, I just had the simple data set here already added of New York buildings. And it can just be generated from building footprints. You can just extrude your building footprints up that are a polygon. And what you would do...
Where do you get the building footprints from?
These building footprints are all from OpenStreetMap. So you can always grab them from OpenStreetMap and bring them in the Pro and generate the buildings. Or in City Engine 2016 and up, there's an actual tool that ties directly into OpenStreetMap buildings and will actually download the data set and run a rule to extrude it for you already. So you have those are the two ways you would generate those buildings. Once you, like in Pro in this case, you would run the layer 3D to feature class. So once you extrude these buildings up in the 3D layer pane, you would apply this tool to take your what would have been 2D polygons and creating them into 3D space. So that way you can generate these all these New York City buildings. And when you have these New York City buildings, you could just share. You can share them from ArcGIS Pro as a web layer. Right now, we kind of we have some blocks in publishing this 3D data to ArcGIS Online. So if you try to share this as a web scene as its entirety, it'll block it in this case because we don't read the multi-patch data set that's being generated on the fly right now. That's why I'm going to be showing you a slightly different workflow. But if you are using Portal for ArcGIS, it's a very easy one-click solution. So once you have these extruded buildings, you would just go to Share and then go to WebScene, and that would actually generate the web scene for you, the 3D object scene layer, and the hosted feature and the feature layer behind you. But where we're talking about ArcGIS Online, it's a slightly different workflow where you would, in this case, you could go into either ArcMap, and here's the building data, that same multi-patch data set, and share it as a service, and go through that same process of publishing a feature service from ArcMap. Or in the case of Pro, in this release, you'll just have to drag it down into the 2D pane right now, just because it thinks that you're trying to generate a scene layer when it's in the 3D level right now, which it's not supported. But one, sorry, is that you? Okay, sorry. So then you would, so then it's just in the 2D pane, and you just right-click on it, and you just go into share it as a web layer. And then you start the publishing process of publishing this up as a feature layer, and then it'll create that feature layer within ArcGIS Online. So those are the couple of ways that you would take the data set from a file geodatabase and get it into ArcGIS Online to generate that feature layer. The third workflow for getting this data in, just because let's say you might have downloaded that data from an open data website that might have had all those 3D object buildings also present. You could also go through the add item from my computer workflow and choose that zipped file geodatabase with all the multi-patch features in there and upload that and begin the publishing process of the feature layer. The output will just be like this guy right here. This is just some New York City buildings. I can go into the data tab and see that this one only has like 30,000 features in there from that clip data set that you saw here. And underneath the visualization tab, because multi-patch features are only supported, multi-patches in a feature layer are only supported in 2D. They just show up as, let's see. They just show up as just building footprints. They almost look like just like a polygon layer. But now that you have that actual feature layer, you want to publish it as a scene layer. So going on the item detailed page on the overview section, just clicking on publish and selecting that scene layer option. It's beta right now. We just released this in December, and it'll be in final at UC. And this is where you can start entering in the metadata about the scene layer that you're going to want to create. But one thing I want to talk to you about is this bottom section, this display in global or local. So let's say you had everything in New York State Plain that you published up in that zipped geodatabase, because that's what the New York City provided you the data set in from their open data website. But everything that you're working in is in Web Mercator or WGS84, and you want to use it in a global scene. Well, this gives you the option to actually choose to show your scene layer or cook it in a global scene sense, to use it with Esri's base maps. Or if you had all your own tile services or vector tile layers already in New York City State Plain projection, you could go ahead and just choose that option and it'll cook it there, so then you could use it all in a local scene just for New York City. In this case, I'm going to be using it with Esri's provided base maps and elevation layers. So I'm just going to go ahead and I just click OK. And this starts generating that 3D object scene layer. And the output of this will look just like, this is what we'll end up seeing. We actually tell you what kind of scene layer you're looking at. That section I just highlighted, it'll say the 3D object version. And we also always show what it's been created from. So you can always jump back and forth between your feature layer and your scene layers to see what's tied to one another. So this is a really handy way to navigating between the layers that you're publishing from other layers. But another thing I want to show you is that we added in this most recently release. We also allow you to manage your scene layer cache. And so in the scenario, let's say you're editing these, you might have point layers or your multi-patches being edited out in the field. So in the case of those New York City trees, and I sent another collector team out and they collected some more trees and they synced it back to the feature layer, I can go to my scene layer that I've cooked, because it's a cache. It's a static picture of what was used at the publishing time. I can actually go into the manage cache and select the layers within this scene layer to actually rebuild the cache on the fly. So if your data in that feature layer is ever changed, you don't have to delete it and then completely republish it. You can pick the specific layers that have been altered in that the companion feature layer, and rebuild that cache. So it's really speeding up that workflow of changes and rebuilding, changes and rebuilding. So, and something that we're going to continue on making it more and more efficient. But this is a great way to kind of manage your scene layer caches. So now I just want to show you what the end up building. You can just add in these buildings into the scene viewer. And once it comes in, it just zooms down to the level of detail. And then we just get the attributes that were present in the feature layer, whatever renderers we're using. In this case, it was just a simple renderer, and any of the other dependencies on the data. But you'll notice that in the scene viewer, the actual customization of 3D object scene layers, it's kind of limited to this at this release, I can only change the colors of the, I can only change the tinting on the actual buildings and let's say turn them red. I can't do like a class break or a unique value right now. It's just something we're working on and we're planning on getting it in there for the UC. So at this release, the trees, that's all point scene layers or point feature layers. That's out there and it's released. But in the case of the 3D object scene layer, that's a UC release to support smart mapping. But I want to talk to you about how do you actually, I'm going to hand it over to Kristian to actually show you how to actually take this New York City scene layer and bring it into his own custom application and some of the great configurations that you can do with it there. Thanks.
Can you switch? Yep. Can you guys hear me okay? Okay. So I'm here at this item detail page for the scene layer, this hosted scene layer that Russ created. And as Russ pointed out, the scene viewer currently is kind of limited to what you can do with visualization. So a lot of the apps that we see today are all about data visualization and telling a story with the data. And so if you want to add a class breaks renderer or you want to add continuous color to your buildings or to your objects, you can do that with the JavaScript API. That's already supported. It's just not supported in the scene viewer yet. So what you would do is you would load your layer with that portal item ID that you get from the URL. And then you bring it into a custom app. So I've just got a pretty simple JavaScript application here. You'll recognize the require and all these imports. Just by show of hands, how many of you have built a 3D app before? I just want to know how familiar. Okay, so most of you haven't, so that's great. So the scene view is the view that you would work with when building a 3D application. In 2D, it's strictly the map view. But because we're dealing with 3D data, we want to use the scene view. And you'll notice something that you probably may not be used to, and that's importing the layer class. In our samples, you see a lot of Esri layers, feature layer or scene layer. Maybe it's a tiled layer. We have different layer types that you might be directly importing. Here I'm just getting the base class, and there's a reason for that. You may not know what layer type you're getting from the portal. In this case, we do know it's a scene layer. So, but you can call a method on the layer class to create that layer instance for you. So here's my map. I'm bringing in some the default world elevation layer, and then I create my 3D scene view. I've already configured the camera so that we're looking at New York City, or Manhattan in particular, for a particular view. But if I wanted to, I could program the app to behave the same as a scene layer and just zoom to the full extent of the layer. And I'll just add a legend widget since I want to see class breaks in my data. So this is what's going on. When the view's ready, or when its promise resolves, we're going to call this from portal item method on the layer. And this takes an object that has a portal item property, which is essentially another object that describes this item that we want to take. And so we paste that item ID into the ID property of this, and then we can add it to the map as is demonstrated with the add layer function. So it's pretty simple, and we'll take a look at it right here. So this is the same exact data that Russ cooked and created, put it on the ArcGIS Online. But it's pretty boring, isn't it? There's not really anything to it. There's no texture. We tint it with just gray. We want to tell some kind of story. So we have APIs to allow you to do that. So I wrote this function called create visualization where it takes a layer object, and I'm going to set a title on this, call it New York City Buildings, because as you'll see from this legend, it's not very helpful, this default title that Russ didn't change in his item details. Looks terrible. So you can change that, override it in your function here. So I'm just going to call it New York City Buildings, and I'm going to create a new class breaks render, and I want to tell some kind of story with the construction here. I want to see how old and some of the buildings in New York are, and where those buildings are located. Maybe see some spatial patterns in there. And so I'm going to create a default symbol. The symbol we deal with 3D objects is the mesh symbol 3D. So in this create symbol function, I'm just going to take a color and then return this mesh symbol 3D, which takes any number of symbol layers, but we're going to just define a basic fill 3D symbol layer and assign a color to it. I'm also presenting on 3D visualization later this week on Wednesday, I guess tomorrow. We're going to go into the weeds of 3D symbols. So if you're into 3D visualization and you want to learn more about the structure of 3D symbols, we talk about symbol layers and how these are all constructed and when you want to use certain types of layers. So I definitely recommend that session if you're interested in that. So you can see I'm creating just a default symbol, a gray one here. And then for each class break, so for buildings constructed between the year 1900 and 1925, I'm going to give it this dark blue color. And then for the next 25 years, a lighter blue, and the next 25, an even lighter blue, and then it kind of goes into a pale green, and then a yellow color for the most recent ones, built since 2000. So let me comment out this for now. So let's go ahead and add that visualization to the layer. So we actually don't need to add this to the map because it's already there. So we're going to add that function to our chain. Create visualization, save it, refresh the app and see what it looks like. And there we have our buildings. So that's kind of interesting, right? We see some colors, we see a few patterns, we have a nicer legend with a better title, construction year. And so you can see that there's newer buildings here in Lower Manhattan, and as you go up in these middle areas, you see pockets of these buildings built between 1900 and 1925. And then there's some buildings that don't have a year assigned to them, so they have a gray symbol, like down here it looks like that some of these buildings are that way. But we can use visual variables to add another element to this story. So let's go back into my code editor and add an opacity visual variable. So here, the class breaks render sets class breaks. So there's no continuous ramps or anything. So I'm gonna just, to the visual variables property, pass in one object for opacity, and I want to base the opacity on the height of the building. And so that's the name of the field that I'm dealing with. And I want to give it a nice name instead of having this ugly field name. I'm going to call it building height in feet. And then I'm going to pass in this opacity ramp. So for buildings that are 30 feet tall or smaller, they're going to have an opacity of 0.2. And if they're taller than 1,000 feet, then they're going to be fully opaque. And so I'm going to go ahead and refresh the app. And then you'll see that in the legend, and then the buildings will render with a little bit of opacity. So these new buildings over here are much taller, they stick out more, whereas some of these older buildings are more faded. So that just goes to show how you can add a little element of customization on top of your layer that you create, and you're not necessarily able to configure it right now in the current version of the scene viewer, but you can easily bring it into a custom app and do custom visualizations with it. And even more than that, we could even save this render back to the layer item, and then you can still view it in the scene viewer, although it's the configuring ability is not in there yet. You can also do more things like add a pop-up template. So let's say I want to be able to click on the building, I want to see the construction year and the roof height and things like that. Let's go ahead and add that as well. And so I'm not bringing in the pop-up template class because it's going to autocast as a simple object, which is a neat feature about the 4X API. And so if I refresh this, I'm going to have a nice pop-up template. I should have clicked and showed you how bad the pop-up template looks by default. But you get the idea. You can create this custom pop-up template. You can format these numbers so they look nicer. But well, I think what's cool with the new workflow that's in beta, from publishing from a feature layer to a scene layer, you can actually configure the pop-up on the feature layer that's linked to that scene layer, and it will work in here. So I'll pass it over to Russ, and he'll show you how to do that, and then we can show you in this app how that works.
Hello? There we go. So that workflow, when we kind of speak it out loud, it can be kind of confusing. So this is why we're showing it to you right now. So here, this is pretty much the parent feature layer that I generated from that published that scene layer. And I could open this up in the map viewer, or I can just quickly go over to the visualization tab. Then I'm just going to go to the configure pop-up. I'm going to just delete a part of the pop-up title. And I can configure some of the attributes that we want to display. So I'm just going to choose the construction year and the number of the floors. And just save my pop-up. And I want to make sure I click Save Layer. This is going to save that pop-up configuration that I just did here on the feature layers item detail page and apply it to the item. And so what's going to happen is the scene layer will then leverage this pop-up configuration. So I'm just going to pop it over to Kristian.
Okay, so I'm going to get rid of the pop-up template here. Oops. Save it. So this is the former pop-up. And I'm going to go ahead and refresh. And I get Russ's pop-up. So it's the scene viewer is getting better with each release, making these workflows a lot more simple and easy for you to work with. So that's what we had prepared for you today. We're, like Russ said, we're going to present, is it Thursday morning? We're going to present Thursday morning. We're going to go more in depth about 3D. We're going to build a 3D app from the ground up, starting with the data. Russ is going to configure, create a web scene. I'm going to load it into an app and do some more things with filtering, just more custom functionality. So you're certain welcome to come to that session. I encourage you to. We're going to go ahead and open up for questions. Do you guys have any questions about Russ's workflow or the customization in JavaScript? We'll go ahead and open it up. Or is that completely clear? It's crystal. Yes. A layer, oh, so a definition expression? Sure. I just hope that I don't like crash and burn right here. So I'll just keep it in the same function, or we'll just do like, so function, add definition expression. Let's get the layer, and then we'll say layer.definition expression. And then we'll say construction year, before 1925. Okay, return the layer. And add definition expression. Crossing my fingers. And oh. What? Let's see, do I have it? Layer.definition expression. Typos. Okay. Please work. There we go. Yes. So that was not previously available before 4.3, before last week released. So it's something that seems really basic, like because we're used to that with feature layers and map image layers, but scene layers, as you can imagine, are a lot more complicated to deal with because of the cached attributes that Russ was talking about. Sometimes a field will allow you to set a definition expression, but not allow you to set a pop-up or a renderer or use it for rendering. So we've come a long way in the last few releases to allow you to be able to do this. And you can also query scene layer to return 3D extents and yeah, just feature objects as well. Okay. All right. Yeah, feel free to find us over here and we can answer more questions. So,
Sorry, Brent.
thanks for coming.